everybody, and welcome to another video. In this one, we're going to do topic 2, lesson 4, example 6, and we're going to conclude this whole book with the conclusion or the concepts that you need to know from this lesson. All right, so in this one, we're going to take the last example of the sum of squares, and we are going to use that idea to solve for a quadratic. All right, so first let's look to see if we have a GCF. And looking at these two, we don't. I mean, it's 1, but 1 is found in everything, so no, we're good. All right, so now we need to factor this. So remember, if you have a squared plus b squared, or if you're just joining us in this video, if you have a squared plus b squared, this will equal a plus bi times a minus bi. All right. So my a in this case is going to equal x. My b in this case is going to equal 2. Because remember, these are squared, so basically you're taking the base and not the square. So I'm going to look at this. This is going to be x plus 2i times x minus 2i. Now, this is a zero product property. And with a zero product property, one of these factors has to be equal to 0 for our solution to come out as 0. So that's what I'm going to do. I'm going to say x plus 2i equals 0. And x in this case will have to equal negative 2i. Second one is going to be x minus 2i equals 0. And that means x has to equal 2i. So my solutions to this problem are, like I start with a 2. X is equal to positive or negative 2i. And that's the solution. We're done. There's nothing more to this. So if you remember, this one is pretty easy. Let's talk about the difference of squares really fast. So if you guys are populating a formula sheet, you can actually put this in your formula sheet. And that's the difference of squares. So this is the sum and this is the difference. And the difference between the two is the minus sign versus the plus sign. I'm going to draw a square there because I can't fit squares. I don't know what kind of square that is, but it's a square. All right, so there is example 6. Let's go over. And looking for relationships, you solved a similar problem by taking the square roots of both sides. This example provides an alternative method that utilizes factoring. So here's their solution. It's just like mine. It's very detailed. It's very nice. They do the 2i's here to get the 4 because they do make it into a difference of squares. If you can memorize this formula, if you can memorize this right here, you won't have to convert it to the difference of squares. And your try is to take these two and solve them. Let me grab this last one. This last one's actually a good one because it's not perfect and there's not. Do this one for you. Okay, in this case, again, I'm going to do a plus bi, a minus bi. So I'm going to figure out which one's a and which one's b. Well, a right here is 9x squared. But remember, this right here is representing a squared. So to find a, I'm going to take the square root. And I get 3x. B is 25. And remember, that's b squared. B squared equals 25. So b is going to be 5. I know in the past I said do the plus and minuses because you can have those types of answers, but we're just going to take these values, just the values. We're not going to have them plus or minus. I'm going to take these values and plug them into our formula. So now we have 3x plus 5i times 3x minus 5i. And that's it. And now we have to solve for it. Well, 0. So again, we're going to solve for x. I believe x is going to equal positive or negative 5i divided by 3. All right, guys, so let's look at the very end. We are done with all of the examples for this concept. We do have the concept summary. And again, these are great to look at because these go over just what we've done. These are a quick reference to everything that we went over this lesson. And I hope that you guys have a wonderful day, and we will see you in the next video.